There's some matrices of numbers that we've studied that end up being infinite, totally non-negative matrices. First of all, we have the matrix of binomial coefficients. So if we put the binomial coefficients in a matrix essentially as Pascal's triangle, we have a left justified Pascal's triangle. And we put, say, zeros above. So we've got Pascal's triangle is a lower triangular infinite matrix with zeros, with ones in the diagonal and zeros above. And this matrix is totally non-negative. And the proof is we can draw a planar network, which is an infinite planar network, where these numbers count paths in the planar network. So it is the path matrix of the infinite planar network So if we orient edges upward and to the right, then, and if we label sources, let's say top to bottom and starting with 0, and sinks over here. So we'll have this rare case where a source and a sink are the same vertex. Then, like if we start at S2, then if we go to T0, T1, and T2, we see there's one path, two paths, and one path. That gives the 1, 2, 1. And we can check that this works infinitely. So this is an unweighted planar network, and it doesn't need to be weighted. But if we weight vertical edges strategically with powers of q, then we get a similar total non-negativity result for the infinite matrix of q binomial coefficients. All right, so that's one matrix, actually two if we do the Q version, although I'm going to let you do that for homework. Another infinite matrix that's known to be totally non-negative is the matrix of Eulerian numbers.
So
Remember, the Eulerian numbers are the number of permutations in Sn that have k descents. So we have 1 in S1 and S2, 1, 1 in S3, 1, 4, 1 in S4, 1, 11, 11, 1, etc. This again will be an infinite lower triangular matrix, 1 to the diagonal, all the non-zero numbers below the diagonal. Now, unfortunately, no combinatorial proof of this is known, so nobody knows a planar network proof that all of the minors here are non-negative. No, I'm not going to assign that one for homework, but if anybody figures out how to make a planar network where paths from one source to another sink are obviously in bijective correspondence with permutations that have so many descents, then let me know and you can definitely make a paper out of it. The end.